The acceleration of a particle t seconds after passing a fixed point P is given by A is equals to 3t minus 3, given that the velocity of the particle when t is equals to 2 is -5 meters per second. Find 1. Its velocity when t is equals to 4 seconds. And then part 2, the distance covered by the particle during the third second. And then 3, the instant when the particle is momentarily at rest. And the last question, the minimum velocity attained by the particle. So let's go to the first part. In the first part, you're given the acceleration of the particle is given by these. Now, given the velocity of the particle when t is equals to 2 is -5 meters per second, given the velocity. So you're supposed to find the velocity when t is equals to 4 seconds. Now there's something that you need to understand. I'm going to draw it here. When you're given displacement and you differentiate displacement to get velocity. When you're given velocity, you differentiate velocity to get acceleration. That is the downward movement. The downward movement we differentiate. When you are moving upwards, we do integrate. For instance, if you're given acceleration, you're required to get velocity. You're moving upward, like in this question. You're given acceleration, you're required to get velocity. So you're going to integrate. So in this question, we shall therefore, velocity will be obtained by, when we integrate acceleration, that is a 3t minus 3 with respect to t. So that is what we're going to do. So let us integrate these, and when we integrate these, we shall have 3 divided by 2 t squared minus 3t plus constant c. So that is the expression for velocity. Now given when the velocity of this particle is -5 when t is equals to 2. So the whole of these will be given by -5. That is velocity. And when t is equals to 2. So you're going to substitute. So -5 is equals to, we substitute t with 2. So we shall have 3 over 2. Then t is 2. Like that. And this working is going to give us the value of the constant, that is c. So we work out these, we get velocity is -5. Then this will give this will give 6, and then this will give 6 plus c. So when you work out these, you realize c is given by -5. Now after getting the constant, now we can get the full expression for velocity. So velocity is therefore given by, we are using this, that is the expression after we integrated acceleration. So it will be 3 divided by 2 t squared minus 3 t, then the constant c, we got that on as -5. So we have now the velocity to require. Now what is remaining is just to get the velocity when t is equals to 4. So when t is equals to 4, we just need to take this. So velocity will be given by 3 divided by, we're using this. So 3 divided by 2, t is 4. So this would be 4 squared minus 3. We just substitute the value of t with the 4. Time is 4 seconds. Then -5. So this will give, this is 16. This will give 24. And then this will give 12. And this is 5. When you work out these, you get this will be 7 meters per second. So that is velocity when t is equals to 4 seconds. Now let's go to the second part. The second part is it's the distance covered by the particle during the third second. During the third second, the distance is also known as displacement, which is always denoted by s. So how do we get that? I already did the first one here. Look at these, what I wrote here. Now we want to get s, that is a displacement. So just look at the expression that we have. We have already obtained the expression for velocity, so we shall use that expression for velocity to get displacement. And how do you do this? When you look at v, if you're given velocity, you want to get s, displacement, you integrate, that is upward movement. We integrate velocity to get distance or displacement. So we shall take the velocity, which is already here. So velocity is here. And then when we integrate that, we get distance. So distance will be obtained by, we integrate velocity with respect to t. So let us integrate these. So we integrate these, and now another thing that you're supposed to know before we continue: during the third second. During the third second means what? During the third second means we're going to integrate from 2 to 3, like that. That is what we mean by during the third second. So very fast, we integrate these. So when we integrate these, we shall get to these square brackets here. So we shall have 3 over 6 t cubed. So this will give us a half t cubed. When you integrate 3 over 2 t squared, we will get a half t cubed minus, this will give us 3 over 2 t squared. Then this one will give us minus 5t. Then don't forget, to integrate, we must have that constant. So we are doing these from 2 to 3. From 2 to 3. So from there, we shall now substitute. We substitute the value of t when t is equals to 3. So when t is equals to 3, we substitute that on first. So this will be 1 over 2, then 3 cubed minus 3 over 2, 3 over 2, t is 3 squared minus 5, then this is 3. We're not going to include the constant, since when you subtract, the constant will be eliminated. So we have substituted 3 when t is equals to 3 in that expression, and then we subtract now we substitute when t is equals to 2. So we shall have this will be this will be t cubed minus 3 over 2 t squared minus 5, like that. So we are going to subtract these two. Now we have substituted. So the first one, we're going to simplify this one using a calculator. For the first one, this is what you're going to get, 1 over 2. So this will give 27 over 2. Then again this one, 3 over 2. This one will give again 27 over 2, and minus 15, like that. And then we go to the bottom one now. This one, I have 2 cubed. This will give 8 over 2. 8 over 2 minus 12 over 2 minus 10. So working out these, this will give negative 15, then minus this one will give negative 12. 4 minus 6 minus 10, negative 12. And when you work out these, you will get negative 3. Negative 3 meters. Now you have to understand that distance cannot be negative, so you're going to ignore the negative, take the absolute value, and therefore the distance or the displacement will be given by 3 meters, not negative 3. So that is how you work out that, by simply integrating velocity, and then during that second from 2 to 3 seconds. Now the other part is here, the instant when the particle is momentarily at rest. One thing you're supposed to understand is that when the particle is momentarily at rest, velocity will be 0. When the particle is momentarily at rest, velocity is equals to 0. So you're going to take velocity, the expression for velocity, we had it. So velocity was 3 over 2 t squared minus 3t is 3t minus 5, and just said that when the particle is momentarily at rest, v is equals to 0. So v is equals to 0. You substitute that, and this will give us the value of t, that is when the particle is momentarily at rest. So this one is a quadratic equation, and we just need to reorganize it. And when you reorganize it by multiplying, getting rid of this denominator 2 by multiplying each term by 2, you will get this one as 3t squared minus 6t minus 10. So when you reorganize, you get that is a quadratic equation. Let's use the quadratic formula to solve this. T is equals to, this is a quadratic formula. This is the quadratic formula, where in this case a will be 3. These are the values that you're going to substitute. Then b is negative 6, and c is equals to negative 10. So substituting these values to get the value of t. So t is equals to 6 plus or minus b squared will give 36 minus 4ac. This will give 4ac. This will give plus 120, and then divided by 2a. Just substituting the value of a, b, and c in the quadratic formula here. This will give 6. Taking all these, you get 6 plus or minus the square root of 136 plus 120, that is the square root of 156. This will give 12.49 divided by 6, and so this will give the first value of t. The first value of t, we're going to take 6 plus 12.49 divided by 6. Just take the positive, and in this case t will be given by 3.082 seconds. That is the value of t. So the second value of t, we now take the negative here. So 6 minus 12.49 divided by 6, and this will give negative 1.082 seconds. So those are the two instances when the particle is momentarily at rest. The other part, the minimum velocity attained. Again, you have to understand at minimum velocity. How do you work out that? So at minimum or maximum, at minimum or either maximum velocity, acceleration is equals to 0. So in this case, you shall take to get the time when it attains minimum velocity, you're going to take the expression for acceleration, which is given by, it is here. Just go ahead in the first part. In the first part, a is equals to 3t minus 3. 3t minus 3. So 3t minus 3. So 3t minus 3. So at minimum velocity, a is equals to 0. So 0 is equals to 3t minus 3. So this will give us t is equals to 1. So at t is equals to 1, that is when this particle attains minimum velocity. But now we've not answered the question. Now that is the time when the particle is at minimum velocity. So the minimum velocity, therefore, you have to take the expression for velocity, which we calculated, and we got it as so we got it as 3t squared minus 3t minus 5. So that is expression for velocity. So when t is equals to 1, we just substitute and get the minimum velocity. So 3 over 2, just substitute where there is t, substitute that should be 1. And this will give, when you work out this, it will give negative 6.5 meters per second as the minimum velocity. And that is how you're supposed to solve that question. Thank you.